Inscriptions rated on a certain appliance. If we read on an incandescent lamp, 220 volt, 110 watt, the lamp functions normally and the current passes through it is 0.5. What does each inscription mean? This question I will give the meaning of 220 volt and 110 watt. First, 220 volt called rated voltage and 110 watt called rated power. Find the product of I and U times U. U times I will multiply 220 with 0.5 ampere. So we will get 110 watt. Compare the power and U times I. By comparing the power we have 110 watt and U times I equal also 110 watt. So we can deduce that power equal U times I. What is a power? Power is the product of the voltage across it and the current passing through it. Formula: P equal V or U times I, where P is the power, U or V is the voltage, I is the current. Relation between power, resistor and current. First we have power equal U times I. And we have Ohm's law, U equal R times I, and we will substitute it in equation 1. Instead of U, we will replace it by R times I, so we get power equal R times I times I, and we have 2I, so we can write it P equal R I square. Another relation, also P equal U times I, and Ohm's law we have I equal U over R. We will substitute it in equation 1 here. So instead of I, we will replace it by U over R. So P equal U times U over I. Here U is over U over 1, so we will multiply U with U. We have P equal U square and 1 with R equal R. So P equal U square over R. We conclude that equation 1 P equal U times I, equation 2 P equal R I square, equation 3 P equal U square over R. Application on power. If a lamp marked 1.8 watt in normal brightness, it carries a current is 600 milliampere. Find the voltage of the lamp. First I have the power and current, and we know that P equal U times I. So if we divide power over I, we will get the value of the voltage. So U equal P over I, we will get 3 voltage. Find the resistance. By Ohm's law, we can find the resistance R equal U over I, we get 5. Or we can use the formula related with power كمان فينا نلاقيها بنفس الطريقة. Forms of energy. There are different forms of energy: electric energy, mechanical energy, heat energy, chemical energy, radiant energy. Electric appliances receive electric energy and transform this energy into another form of energy. In case of resistor, the electric energy received by the resistor is transformed into heat energy. Relation between power and energy. If we read on an incandescent lamp 110 watt, the energy consumed in a time t equals 60 seconds by the lamp is E equals 6600 joule. What does the inscription of the lamp mean? 110 watt is called the rated power. Find the product of P times T. So we will multiply 110 by 660. We will get 6600 joule. Compare the energy and P times T. By comparing E equal 6600 joule and the value of P times T is also 6600 joule, we can deduce that E equal P times T. What is an energy? Energy is the power of the appliance multiplied by the amount of time the appliance is used. E equal P times T. E is the energy, P is the power, T is the time. Relation between energy, voltage, resistor and current. First we have E equal P times T, and also we have P equal U times I. If we substitute and replace, instead of P, U times I, we get E equal U times I times T. Also E equal P times T, and we have P equal U square over R. If we replace P by this value and formula, we will get E equal T times U square over R. Another formula, E equal P times T and P equal R I square. If we replace P with R I square, we get E equal T times R times I square. We conclude that first equation E equal P times T, second equation E equal U times I times T, third equation E equal T times U square over R. The last equation is E equal T times R times I square. Application on energy. If a lamp marked 220 volt and 88 watt, find the energy consumed by the lamp during one day. First, energy equal P times T. We have the power 88 and the time is 1 day. 1 day means we have 24 hours times 3060. So we get 7,603,260 200 joule. Find the current and the resistance of this lamp. P equal UI, so we can find the current I, which is power over U. We get 0.4 ampere. By Ohm's law, we can find the resistor U over I, we get 550 ohm. Joule's effect. Joule's effect is the transformation from electric energy into heat energy in an electric device. Advantages: energy consumed is converted completely into heat. Example, lamp, iron. Disadvantages: the heat dissipated is lost. Example, motor, fan. Application: an electric heater consists of three resistors connected as shown in the figure, where R1 60 ohm, R2 30 ohm and R3 20 ohm. The total current equal 3 ampere and I1 equal 1 ampere. Calculate R equivalent. To find the R equivalent, we will calculate first the equivalent of R1 and R2. They are connected in parallel, so we'll use the formula of parallel resistor. So R1 times R2 equal R1 plus R2 equal 60 times 30 over 60 plus 30, we will get 20. Now we will add the R of these two resistors with R3. We will get 40 since they are in series. Calculate the power consumed by the heater. Okay. We have the R equivalent and we have the current, total current. So we will use the formula I square equal 40 times 3 square, we will get 360 watt. Calculate the energy consumed in kilowatt hour by this heater during 2 hours. First, we will find the value of energy in joule, then we will convert it into kilowatt hour. E equal P times T, 360 times 2 times 3060, we will get 2,592,000 joule. To convert it into kilowatt hour, we will divide this value over 3.6 times 10 power 6, we will get 0.72 kilowatt hour. Calculate the voltage UBC across R1. We have I1 and R1, we will multiply them to find the voltage BC. So equal 60 times 1 equals 60 volt. Show that the current by R2 is I2 equal 2 ampere. Apply Ohm's law. We have the voltage BC and the current R2. We will divide them to get the value of I2 equal 2 ampere. Or we have the total current 3 and I1 equal 1. Since they are in parallel, we will write I equal I1 plus I2, then I2 equal I minus I1. We get also 2. Calculate UAC across R3. AC we have the total current I and R3. So we will multiply 3 by 20, we get 60 volt. So that the total voltage U is 120. We have voltage AC and BC. Since they are series, we will add them to get 160. Or by apply Ohm's law, we have the total resistance and total current. 40 times 3 equal 120 volt. Calculate the power across R1, R2, R3. Okay, we have the voltage BC and I. So P equal UI, P1 equal U BC I1, we will get 60. P2 also U BC I2 equal 120. P3 equal UAC times I equal 180. Verify that the total power is P equal 360. So we will write P equal P1 plus P2 plus P3. We will get 360.